Hello students, welcome back to the channel. In today's video, we will be discussing about the factors which bring about the chemical changes or reactions. Okay, so as we know, whenever a chemical reaction takes place, it always involves the breaking of existing bonds and formation of new bonds. And whenever this process is happening, it always involves the absorption or release of energy that can be in the form of heat and light. Okay, and whenever heat and light are bringing about these changes will initiate the collision of particles in close contact with one another by supplying the heat energy or the light energy. So what is heat energy actually doing? It is initiating the reacting particles to move faster and collide frequently. And when we are talking about light energy is absorbed by the reactant molecules, making them much more activated. So overall, what is happening? Heat and light energy and other factors are also there, like catalyst is there, pressure is there. All these together bring about a change in a chemical reaction. So you need to understand, when we are discussing the reactions, that whenever a particular thing is mentioned in a chemical reaction, those factors are actually helping in bringing about a chemical change in that given chemical reaction. So first of all, we are going to see what a reversible reaction is. It is a chemical reaction in which the products react together to form the original reactants again. So for example, if A reactant is reacting with B, it is forming the products C and D, and again they can change back to form the original reactants, that is A and B. Okay, A and B are the reactants, C and D are the products. So firstly, you need to know the definition. What is a reversible reaction? It is a chemical reaction in which the products react together to form the original reactants. So let's see the first reaction. We have sulfur dioxide reacting with oxygen, and definitely it will be a reversible reaction, okay, forming sulfur trioxide. Okay, so this is a simple reaction which you can remember for a reversible reaction, and conditions mentioned are the catalyst used is vanadium pentoxide and the temperature required is 450 degrees Celsius. Okay, so this is the first reaction which you can remember under reversible reaction. The second reaction is nitrogen reacting with hydrogen. This is the most important reaction which you will learn, because later on in your higher grades you have this chemical reaction for examination. Very important. That is the reaction to form a basic gas, that is ammonia. We get 2NH3, that is ammonia, and here the catalyst is iron and the temperature required is 450 degrees Celsius. So these are the two important reactions which you are going to learn for a reversible reaction. Okay, moving on to the next, that is a catalytic reaction. It is a chemical reaction in which a catalyst alters the rate of the reaction. So remember, it will only alter the rate of reaction, but the catalyst never participates or does not take part in a chemical reaction. Okay, so catalyst does not take part in a reaction. Okay, whatever chemical reaction is, it will not participate. Okay, so here we will see three important reaction. Earlier also we saw just now for reversible reaction, that is the same reaction. First I am going to write down, that is the reaction of sulfur dioxide with oxygen in the presence of the catalyst, that is vanadium pentoxide, and the temperature required is 450 degrees Celsius. So both the conditions you need to learn. We get sulfur trioxide. Okay, so here, because we are talking about the catalytic reaction, you should remember the catalyst, that is vanadium pentoxide. Second reaction is again the reaction of nitrogen with hydrogen. Just now again we saw this reaction, we are getting ammonia. And what is the catalyst here? Do you remember? Yes, the catalyst is iron here. And one more thing I am going to add, it has a promoter, that is molybdenum. MO is the symbol, and the temperature required over here is 450 to 500 degrees Celsius. That is the temperature that is required for ammonia to form. And the two important conditions are, firstly, the catalyst used is iron. What is molybdenum? It is a promoter. A promoter only increases the efficiency of the catalyst. Okay, and iron is the catalyst over here. And what is the work of a catalyst? It increases the rate of the reaction. It is changing the rate of the reaction. It is altering the rate of the reaction. And in the next part, we will also see that a catalyst can be of different types. It can be a positive catalyst, a negative catalyst. So positive catalyst will always fasten a chemical reaction. Negative catalyst will slow down the rate of a reaction. The third reaction which we will see over here is the reaction of ammonia with oxygen. Ammonia, when it reacts with oxygen in the presence of the catalyst platinum. Now the catalysts are very important here because we are talking about the catalytic reaction, so you should know all the catalysts which are being used. We get nitric oxide and water. So what is the catalyst that is used? Catalyst used over here is platinum. So first two reactions we saw it for reversible reactions, so you can remember the same reaction for catalytic reaction also. Okay. So yes, what is a positive catalyst? It speeds up. It will speed up. It speeds up the chemical reaction. Example is all the above reactions which we saw, that is the catalyst which we saw was vanadium pentoxide, then we saw the catalyst iron, and then we saw the catalyst platinum. All these will speed up the given chemical reaction. And what is a negative catalyst? It reduces the rate of reaction. Reduces the rate of reaction. And in this you will remember the example of alcohol. Okay. Example of a negative catalyst you will remember is alcohol. Okay, it reduces the rate of reaction. And what is a promoter? Promoter, we saw the example of molybdenum. Molybdenum will increase the efficiency of the catalyst. So what is a promoter? It increases the efficiency of a catalyst. Okay. So these three things you will remember when you are learning the catalytic reactions. Okay, we have a positive catalyst, negative catalyst, and promoter is added to the catalyst to increase its efficiency. Okay, next we will see exo and endothermic reactions. Firstly, the definition is important. Exothermic reactions are the chemical reactions which proceed with the evolution of heat energy. So if A is reacting with B and the product form is C, if heat energy is evolved, you are going to represent it with a positive triangle. So this is an exothermic reaction. And in the same case, if again A and B is reacting to form C, and if I write a negative triangle, then it will be classified as an endothermic reaction. What are endothermic reactions? Which proceed with the absorption of heat energy. So here also few reactions we are going to see, some of which are again the repetition of what we have already discussed. So if you remember 2-3 reactions, you can cover all the factors, like you can cover the different types of reaction, that is reversible reaction, catalytic reaction, exo and endothermic reaction. So we saw this reaction of sulfur dioxide with oxygen. It is a reversible reaction. Catalyst used is vanadium pentoxide. Temperature required is 450 degrees Celsius. We are getting sulfur trioxide and it is an exothermic reaction. Okay, so what are the three things which we are covering in this one reaction? Reversible reaction, catalytic reaction and exothermic reaction. So this reaction you can learn, it will cover all the three things which we have discussed till now. Second reaction which you can remember is, again, as I told you, the formation of ammonia is a very important reaction. So nitrogen with hydrogen reacting, again it is a reversible reaction, okay, and we are getting ammonia being formed, 2NH3, and again it is an exothermic reaction. Okay, then what are the other things you need to remember? When nitrogen and hydrogen are reacting, what is the catalyst that is used? Iron. And the promoter used is molybdenum, and the temperature required is from 450 degrees Celsius to 500 degrees Celsius. So whenever you're writing these reactions, whatever conditions are mentioned, you need to learn all those conditions. Then one last reaction we will see for endothermic reaction. Endothermic reactions are those which proceed with the absorption of heat energy. So nitrogen, when reacts with oxygen at a temperature, at a very high temperature, that is 3000 degrees Celsius, it forms nitric oxide, and this is an endothermic reaction. So whenever you are writing the endo and exothermic reactions, please be very clear with the symbol which you are going to write. The plus is for the exothermic reaction, and the negative sign is for endothermic reactions, that is absorption of heat energy is taking place. Okay, one last reaction we will write for endothermic reaction. This reaction you will again see in the chapter of water, that is formation of water gas. Carbon and water, water in the presence of steam, we are reacting. So when steam is reacting with carbon, it is forming water gas, CO and H2. Together you write them as water gas is being formed. And here again temperature is important, 1000 degrees Celsius, and this is also an endothermic reaction. Okay, so in this particular factors what we have discussed, which are helping in to bring about a chemical reaction, the reversible reaction we saw, catalytic reaction, exo and endothermic reactions. If you learn these three reactions, you can cover all the types what we have discussed. You are covering the catalyst also, the reversible reaction, and exo and endothermic reaction. So whatever reactions we have discussed, please learn these reactions as it is given. Learn the complete balanced reaction so that when it comes in the exam, you don't waste your time in balancing. Learn the complete balanced reaction for these types of reaction. So in the next video, the things which we'll be discussing will be the decomposition reactions to form different type of oxides, and we will also be talking about the other thing which is the oxides, what are actually oxides. And please go through the lesson and learn all the reactions. Thank you, students.